Okay, good afternoon. And thanks for joining the virtual press conference with the Tiger Eye 1 research team. My name is Allison Satake. I'm with the LSU Media Relations Department. And we're just so excited to share this research with you all today. I'm going to ask all of the members of media if you can hit mute on your microphones. For right now, that would be great. We are recording this presentation and we can share the Zoom link with you all for broadcast purposes. Today, here's what's going to happen. The research team is going to talk about their work and the upcoming mission that will place science and research technology developed right here at Louisiana State University in Baton Rouge on the moon. You will get a chance to hear from each of the members of this team today. And you can submit questions through the chat box on your screen. And we will address your questions after the team's presentation. Let's see. So like I said, we are recording this meeting and we'll share the Zoom link with any of you who would like to use it. And so now I'd like to introduce Dr. Jeffrey Chancellor, who is the lead researcher on this project. Dr. Chancellor is a nuclear physicist and an expert consultant on radiation effects for manned spaceflight and the aerospace industry. He is currently an LSU Department of Physics and Astronomy assistant professor and the chief technical officer at Atlantis Industries. At LSU, Dr. Chancellor is also the director of the Space Radiation Transport and Applied Nuclear Physics, or Spartan Laboratory. The Spartan Lab's research is focused on applications of how heavy ion radiation interacts with soft and condensed matter for ground-based analogs, manned spaceflight vehicle structure, shielding, and clinical healthcare. The Spartan Lab utilizes 3D computer modeling technique, high-performance computer platforms, multi-core computers, and sophisticated numerical techniques for studying complex dynamics. Prior to LSU, Dr. Chancellor was a research scientist at Texas A&M University. He was also the Radiation Effects Program Manager at the National Space Biomedical Research Institute and held an academic appointment at the Center for Space Medicine at Baylor College of Medicine. He also was a senior research engineer at NASA's Johnson Space Center. As part of the Space Radiation Analysis Group, he served as the flight controller on the Radiation Console in Mission Control and as the radiation lead on the mission management team for several space shuttle missions. He was responsible for projecting the radiation exposure, briefing the astronaut crew on any health risks associated with mission, informing the mission manager of the radiation risk assessment, and providing a go, no-go recommendation. Additionally, Dr. Chancellor worked extensively with the design team for the Constellation program's Orion Crew Exploration Vehicle and led the effort to reach an optimum mass configuration that would maximize the shielding during solar particle events. He also provided training in space weather, medical physics, and countermeasure procedures to astronauts preparing for missions on the International Space Station. Now I'd like to turn it over to Dr. Chancellor, who will introduce the Tiger Eye 1 research mission and team. Dr. Chancellor?
Great, thank you, Allison. Thank you everyone for showing interest in this really cool project. We're really excited about this opportunity and to discuss some of the exciting things that we're working on. So right now we are designing custom hardware that will be put on the Intuitive Machines Nova-C moonlander that is scheduled to launch. It's supposed to launch into this year, but now they're saying it could be the first of 2022 to the lunar surface, where it will operate on battery power for 2 weeks. So what we are jumping on this for an opportunity is a chance to actually measure the radiation environment from the lunar surface. The environment in space is radiation is much different than what we see here terrestrially. There's a lot of implications and beliefs that it could be detrimental to human health, but we have proved that it is either not or is so far. So we're still trying to understand all the effects. And one way to do this is to actually collect the data so that we can compare it to predictions and models that we use to try to understand what are the effects, not only to human health, but also to the hardware operating on the surface or any type of infrastructure that'll be used on the lunar surface during these missions. So this will be the first instance of a US institute actually measuring the radiation environment on the lunar surface since the beginning of the spaceflight program at NASA and with our international partners. So we're very excited about that. And we hope a lot of what we will show is the efficacy of being able to put together this type of detector, work through the kinks, because we haven't been back to the moon in 50 plus years now, and make sure we understand how to create this type of capability for the second mission, which is supposed to launch at the end of 2022, where we'll put a little bit more robust capability on the vehicle in terms of detectors, because it'll also be operating via solar power, and so it'll operate continuously for as long as the equipment functions and doesn't fail. I kind of stumbled on this opportunity, and I saw a good chance to engage some of the students here at LSU because I've been a part of many missions before. I knew this was going to be uniquely challenging, but not overwhelming, because we've been doing this for a while and we have a lot of experience putting these packages together, and working with a commercial entity as opposed to NASA is a little more fluid and dynamic. So we assembled this team of physicists or engineers who can look at this as a way of doing a real world project management of, in this case, a spaceflight mission, and learn how to deal with milestones and deliverables, setbacks, and the continuous changing of requirements that are involved with a space mission. So it's been a lot of fun to be part of this, and we're looking forward to doing many more of these in the future. Right now, we're preliminary. Just started working on developing a similar technology detector for the Inspiration 4 mission that's going to launch in September on SpaceX. So with that in mind, I think a lot of excitement came not only from this idea and concept of being, putting LSU and the Department of Physics and Astronomy on the lunar surface here this year, but also from the patch itself that Katie designed. And one of the reasons I wanted to create a mission patch specifically for us, because it's just an old NASA tradition where if you have a spaceflight mission or you have some type of hardware that's going on a mission, you typically have an acronym or a mission name, and you develop a patch. And it's not only a way for the team members who are directly involved, hands-on working on these experiments or developing these hardwares to kind of show a little camaraderie, but it's a good way to incorporate all the people who work behind the scenes and support the mission, whether it's procurement or intellectual property or public relations. So it allows for them, because they put a lot of effort into enabling us and putting the gears in motion for us to be part of this mission. So it's a way for they can not only just to thank them, but also show them they're part of the team, and they can go get a polo shirt or a fleece that I have on here with the logo on it and brag about being part of this itself. So with that, I'm going to stop and turn it over to Katie and let her talk about the patch itself and how she came up with the design while I'm working with us.
Hi everyone, my name's Katie. I'm a senior graphic design major here at LSU, and I had the really cool opportunity to work on the logo design for the Tiger Eye 1 mission. And so I'm just going to talk about how this design came to be. It actually started as a collaborative project with the LSU Graphic Design Student Office, and that is just a group of undergrad and graduate graphic design students who work on professional client projects internally with the university, such as this project, and externally with local community organizations. And so earlier this year, one of my professors had reached out to me to join GDSO this semester, specifically to help work on this mission patch design. And I saw it as a really cool opportunity, so I immediately jumped on board and agreed to help. And so The design process, it began with a conversation about the mission, what it's about, what it does, and who it represents. And so we talked about what symbolism we wanted to include in the design and how we wanted the public to perceive the mission. And so we came up with a lot of different initial concept sketches. Each person in GDSO came up with about 3 to 4 different concepts on how they interpreted the mission. And so we shared a bunch of different ideas and constructive feedback, and we probably had at least 30 different designs to pick from. And eventually we narrowed it down to a couple designs, from which Jeff eventually chose my design concept, which is what you see here. And so before coming up with the design for the patch, I did a lot of research on different patches from past space missions. As Jeff said, it's kind of a tradition for a patch design to be made when there's a mission happening. And so most of the patches that I researched were very literal depictions of what the mission entailed. And so I really tried to emulate that particular style by literally representing the mission in the patch design. And so it shows what the mission entails. It's going to the moon and who it represents, and the name of the mission, which is Tiger Eye 1. And I really wanted to emphasize that this is an accomplishment of LSU. And so I implemented LSU's branded colors, the purple and gold. And of course, as we all know, as soon as you see purple and gold, you think immediately of LSU. So I really wanted to emphasize LSU in the design. And talking about the design concept, the composition, I was influenced by sort of yin yang shape where it balances the eye and the moon, and thought it looked really cool. And so whenever we were talking about ideas of symbolism to include in the design, we thought about how this device is detecting radiation from the moon that could potentially be harmful to astronauts. That's what they're trying to figure out. And so the tiger eye looking down over the moon kind of symbolizes like an all-seeing eye, and it's kind of overlooking the mission and LSU, how LSU is really helping the world better understand lunar radiation and how we can protect future astronauts from potential harm when they visit the moon. And so in my research, I also learned that a lot of mission patches include some sort of like hidden symbolism that might represent the people who are part of the mission. For example, sometimes the amount of stars like in the sky might represent the children of the astronauts who are going on the mission. And so we asked Jeff if there's any like hidden messaging he wanted to use, and he actually said no. And he said it was because he really didn't want the mission to represent him, but he rather wanted to represent the university as a whole and how this is an accomplishment of LSU. And I thought that was really cool. And so when designing the final patch, I came up with several different iterations and layouts for Jeff to choose a final design from. And the one he ended up picking was actually my favorite version. So I'm really glad that the one that you see here is the one that he picked and decided to represent the Tiger Eye 1 mission. I think it turned out really cool, really awesome. It was an incredible honor to be able to design for such an important occasion for LSU. And yeah, so I'll just go ahead and turn it over to Haley, and she's going to discuss her part in creating the device for this mission.
So, hey everyone, my name is Haley, and I actually just graduated in medical physics this past Saturday. So I'm going to go ahead and talk to you a little bit about the role played in this mission from more so a perspective coming from the physics side of things. And so most of the physics behind this mission is going to come directly from the measurements that we will make of the cosmic radiation environment on the lunar surface. This is going to be as we use various computational methods to post-process and analyze this raw data as we actively receive it from the mission. And this also does include the effectiveness of Geosynth's very own novel shielding candidate that they're going to be supplying and incorporating in the lunar lander as well. So, and a novel shielding candidate, this is just a material such as something like aluminum, and it's used to reflect or absorb cosmic rays during space flight in order to protect our human crew and the hardware as well. So as we know, the space radiation environment is very complex, consisting of these galactic cosmic rays that are pretty much a background source of very slowly varying and very highly energetic particles. And because of all the unknowns surrounding, this very highly energetic and potentially harmful environment, it's not quite ideal nor safe to send human crew out there to gather data themselves. So this this further prevents, the probabilities of adverse health effects introduced by these galactic cosmic rays from being measured directly. So this is sort of where we are stepping in here with implementing the Tiger Eye 1 device onto the lunar lander for the IM-1 mission. So pretty much to initiate the start of this process, our first step that was taken was deciding on a radiation detector model that can both withstand these galactic cosmic rays as well as still have the ability to provide readings with good resolution and still meet the mass requirements of that of the lunar lander. So some time ago, Dr. Chancellor actually did some previous work with a company called Abicam. They're based out of the Czech Republic, and even helped to develop one of their earlier radiation detector models technology. So we ultimately have partnered with Advocam and decided to select what's called their MiniPix TimePix 3 detector to use for the mission, which, to give you a better idea or mental image of what this thing actually looks like, after customizing the device, it'll be about the size of an iPhone. So it'll be about this big. Which is perfect because we needed something small in size and lightweight while still being able to meet those requirements we need, to get successful readings of the cosmic radiation environment. And in addition to this, this technology was already previously used for the International Space Station. And so it's already been vetted by NASA for spaceflight. So this made it quite easier for us to act on when it came to boiling down, selecting technology that would be best fit for this mission. And so from that point on, lots of coordinations and collaborations were made with Advocam to create this custom version, of the detector model to make sure we ensure its functionality and compatibility with Intuitive Machines' lunar lander. Once we pretty much set this design in stone, to ensure as much success for our approach as possible, we first went ahead and we made some, general measurements with this same radiation detector model that will be used for the mission. So we were able to get our hands on a demo version of the Advocam's MiniPix TimePix 3 detector. And we actually took this to LSU's vet school's Linear Accelerator and made some measurements there, pretty much for us to have familiarization of the device itself, as well as the supplied software that's actually going to be used for the data acquisition. And so alongside this, we've actually already received some samples of GeoSense novel shielding candidate that's going to be incorporated on a lunar lander. So we're going to go ahead and also take that material as well back to the vet school's Linear Accelerator to do pretty much some preliminary analysis on how well this material actually will attenuate radiation. So in other words, we're looking at how well will this material reduce the intensity of the radiation that's going to hit it. So now getting into as far as the actual data acquisition and analysis during this mission, as we transmit this data from the device in space back to us here on Earth, we're going to use various computational methods and algorithms. So, we're going to do a little coding, software development in order to manipulate this data in a way that's going to ultimately provide us with some very useful and insightful information on the cosmic radiation environment on the lunar surface, which much of what we were doing and intensifying has not really yet been done before. So this can be some pretty big news because, these findings are directly applicable to being able to approach ways of simulating this space radiation environment in a much more accurate manner that can be done within a laboratory setting. And this can also further give much more precise understanding and tactic when it comes to ways of studying those potential radiobiological effects resulting from this radiation environment during an actual space flight. On top of this, this data can also, make advancements for means of designing and modeling radiation shielding itself for a spacecraft that can be used to minimize the dose received by, both the human crew and the hardware during future space travels. But here's one really cool thing about this mission is that since we already will be actively analyzing GeoSense novel shielding material, during the course of this mission, the results we find from this will tell us how well this material in particular can actually withstand and minimize that dose received from the cosmic radiation environment in space. So pretty much if these results are positive, this shielding candidate might actually be able to potentially be used for future missions, which this is incredible because it can put us another step, further when it comes to the future of space travel. And adversely, if any issues were to arise with the results, this is okay since we will have this data on hand. So we might actually be able to pinpoint the issue directly, and this is going to push us in a much better direction on what we need to focus on in particular to go ahead and develop the most effective radiation shielding material possible that could and may potentially be used in the future. But pretty much in all, the data resulting from this mission, I mean, it really can play a huge role in the future of space travel. It has the potential to make major changes in the ways that we approach what's actually possible in space. And hopefully this can put us one step further in successfully taking on long-term space travel like that to Mars. And so that pretty much wraps up everything regarding the role played in this mission from sort of a physics perspective. And I'm going to go ahead and pass this over to Jacob, and he's going to tell you a little bit about the engineering perspective of the mission and sort of familiarize you all with the ins and outs of how, the Tiger Eye 1 device is actually going to work and how it came about.
So hi, everyone. My name is Jacob Miller. I'm an undergraduate senior in electrical engineering, and I'll actually be graduating in December of this year. And my role on the project is to develop the interface between the detector that we've developed with Advocam and the Intuitive Machines vehicle. And whenever I say the interface, I'm specifically referring to the mechanical housing that will actually encase all of the detectors, as well as how we're going to mount that to the Intuitive Machines vehicle, and the electrical connections that we'll be providing to provide power and data transfer to the device, and the software that we'll be developing that will manage all of the communication between us here at LSU and the payload. And one of the really interesting things about working on a mission like this is that tasks that are seemingly simple and straightforward here on Earth instantly become far more difficult in the environment of space. So for instance, we have to design the housing to be able to withstand the intense vibrational forces of launch as we're launching into space. And then once we're in space, the temperatures can vary wildly from extremely cold temperatures to extremely hot temperatures. And we need to be able to select components that can handle these extreme temperature fluctuations, as well as ensuring that our housing will provide a somewhat comfortable operating temperature for the electronics that we have. And then also in space, we have the harsh radiation environment that we'll be measuring. And so the electronics, this radiation environment is very damaging to electronics. And so we have to use very specific electronics that were designed specifically to handle the cosmic radiation of the space environment. And on top of all of that, we have to meet all of these different requirements while weighing in at less than 2/3 of a pound, matching the power requirements of our vehicle provider and taking up about the same space as an iPhone 12. And then apart from just these physical challenges, there's also the software development aspect of the mission. And so in order to maintain contact with the device while it's in transit to the moon and while it's on the lunar surface, we'll actually be setting up our own control room here at LSU, which we'll be able to use to send commands to the device, monitor its health status on the lander, and receive and process all of the data that the lander transmits back to Earth. And then obviously, our hope for the device is that we send it into space, we send it to the moon, and it works perfectly on the first try. But what's far more likely going to happen is that we're going to run into problems while it's flying to the moon and while it's on the lunar surface, and we need to be able to use the data that the lander transmits back to assess the problem that we're experiencing, figure out what's going on, and then fix it from here on LSU's campus without ever actually having to physically touch the device. And then as we further develop for this mission and for IM2 that Dr. Chancellor mentioned earlier, we'd like to grow this control room into a sort of space weather station that will allow us to take all of the data from our detectors and keep this sort of continuous stream of monitoring the radiation environment in space and on the surface of the moon. And I'd like to take a second to sort of go over this figure to give you all a better sense of how the device will operate. So if you look at the top part, this will be one of those little mini PIX detectors that was developed by Advocam. This is going to be sort of the first incidence of the radiation interacting with the device. And then as the radiation goes through below the first detector, we have the shielding material that was developed by Geosynth. And then just below the shielding material will be our second ADVCAM detector. So that we'll be able to measure, first, this is just the radiation that we're experiencing on the moon, and then what we're able to shield with the second detector. And then below all that, we'll have sort of the custom electronics that we'll be developing that will allow us to deliver power to the device and match the communication protocols that are required by the Intuitive Machines lander. And so doing all of this stuff, accomplishing these tasks in and of itself is difficult. And then doing it on the time span that we have to work with really adds a whole new level of challenge and excitement that's really, really interesting to work with. And so I'll pass it back to Dr. Chancellor to talk a little bit more about the upcoming mission itself.
Great, thanks, Jacob. So I'm supposed to fill in anything that Haley and Jacob and Kitty didn't cover, and I don't think there's much they didn't cover. So I almost feel like my job is done here, because this was an awesome presentation, and it's just really exciting to hear them grab onto this and in a short period, under a lot of stressful situations and a lot of hard work, able to learn so much about it. I guess the only thing I could say is the reason we call it the Tiger Eye 1 is because what Jacob was insinuating, it is like a radiation telescope. So that was how we got the idea for Tiger Eye 1. But other than that, I don't think we have anything else that we need to fill in there, and just happy to take any questions.
Great. So we have a couple of questions that some reporters submitted ahead of time. And and then in the meantime, anyone else who's on the call, if you want to type in a question through the chat or raise your hand, and we invite you to turn on your cameras too. This is a conversation. We'd love to see who we're talking to. But here's the first question that came from Aaron at NBC Local 33. And this is to anyone on the team here, Jeff, Jacob, Haley, and Katie. How does it feel to be on the leading edge of this project as part of LSU?
Y'all want to answer this?
Yeah, I could take that one. So it's really, really exciting, because I think, sort of the intense engineering challenges that I was talking about earlier. What's really exciting about being part of this, and in conjunction with LSU specifically, is that, a lot of the problems that we're facing, they're not trivial and they're new. And the fact that we, especially as students, get to tackle these problems and come up with our own solutions, and then have these solutions sort of impact, future space flights and future research that's done here at LSU. It's really exciting to be granted such sort of a meaningful position while still a student here at LSU.
So maybe at this point, I'll point out that one of the reasons I did focus on students was because if you go and you look back at the old Apollo days, most of those flight engineers and flight controllers were in their mid to late 20s. So it wasn't like they had 15, 20 years of experience to bring themselves up to speed. They were given a job, they were told to find a solution, and they went off and came up with creative solutions. And this is what I hope to accomplish. And obviously we are, because Jacob, Katie, and Haley have done some really fantastic work and are really nailing it here. And I guess one of the exciting things about participating in this is, after so many years of working with NASA, which is always cumbersome, it's a government institution, they're very risk averse, and so they take very small steps to move towards progress. Is working with a commercial company to launch something to the surface of the moon is a completely new experience. It's almost like you see all of the mistakes and headaches we've gone through over the past 20 or 30 years come to fruition. Because it's so much easier now. I think Jacob has heard me say it at least a dozen times, dealing with them is like flying, first class on Singapore Airlines, because it's not a typical NASA mission. It's just been fantastic to work with someone who is passionate about it, and they've learned with us at NASA and are now putting it to work.
Katie, Haley, would you like to have anything to add about how does it feel to be on the leading edge of this project?
Yeah, I guess from like a design perspective, this was a really cool opportunity for me to take a part of. Well, the design is really like the face of the mission, and so I really had the challenge of coming up with something that was going to be really iconic and just really cool to represent the mission and for everyone to, I guess, like recognize. Sorry, this is the design is like the symbol of the mission, and it's probably going to be. This is probably like a historic thing because this is like we're the first university to send technology to the moon, and so I think having a really cool design is important as it's going to last a long time and be a part of history. So I thought that was a really cool thing to be a part of as a designer.
Okay, Haley?
Yeah, so I think yeah, being an LSU student and being able to be a part of something that's just so unknown and so incredible, with an institution who, I mean, LSU is amazing and has provided me with endless amounts of opportunities as it is. So be able to be a part of something that is really, putting their name on the map is such a surreal feeling. And, being able to work with space is a childhood dream come true. When you ask a kid, what do they want to be when they grow up? You have kids that say, oh, I want to be a doctor, or they have the ones that say, I want to be a lawyer, or the ones that say, I want to be a superhero. And there's always that group of kids that say, oh, I want to be an astronaut, or I want to work with space. And I think you can guess which group of kids that I was from. But, being able to actively do this, with such an amazing institution like LSU has been such a surreal experience and a dream come true. And I'm really excited to see where the future of LSU's research, in the science field, and especially that coming from, research and work done with space radiation and where that's going to go in the future.
Great, thanks. Here's a question that Kathleen Hilliard from the American Press in Lake Charles sent ahead of time. She wanted to know, and Jacob, you talked a little bit about these challenges. So what were the biggest challenges been thus far, like the parameters? Jacob, you had mentioned like the parameters of designing for space versus Earth conditions or terrestrial conditions. But I'm just wondering, the team, what has been the biggest challenges thus far, and what's kept you going through these challenges?
I would say the biggest challenge was the short run time we had, because we first learned about this mission and were able to jump on the manifest, December of last year, January this year, under the guise that we were launching in October. So we had to have everything done by July of this year, so 6 months. And typically for something like this, you would work on it 2-3 years in advance in preparation. So I would say the biggest challenge would be trying to pull this off in such a short time period, but we didn't have a choice because it was either try it or pass, and we decided to try it.
Anyone else from the team want to chime in on this?
I think Dr. Chancellor hit the nail on the head of what's definitely the hardest part. I know for me personally, not only with the time span of just getting it done, but over the past couple of months, just how much I've had to learn about the mission, and the fact that everything that we learn about it, working with intuitive machines, working with Advocam, and working with some of the other people that I've interacted with, gathering all of this information from 5, 6, 7 different sources, and then trying to piece it all together for what's important for us. It can become a bit daunting.
Haley, Katie, challenges and what's kept you going?
I guess I'll say, like I said, my biggest challenge was just trying to develop a design that would be really iconic, because this is a really big deal. And I really wanted to make a design that was really cool and people could look at and just think it was really cool and want to wear it on a shirt. And but I didn't have a lot of challenges coming up with what it looked like, because like I said, my design was pretty straightforward with the tiger eye and the moon. Um, but yeah, making something really iconic was very important to me. I spent a lot of hours coming up with a bunch of different layouts and sketches until I got something that I think everyone thought was really cool and would be happy with representing this mission.
And I think to add on, being that this is an unmanned mission, I think the anticipation of, anything unexpected that may happen, while it's out in space has been, a pretty big challenge, because if anything adverse happens, there's no one actually there on the lander to, fix it like by hand themselves. So we pretty much have to know how to act quick and on our toes as a team. Like, we have to be used to working as an agile environment. So if anything, unexpected or adverse were to come up, we need to know how to put our strengths together, act quickly and effectively, and be able to adjust to what's going on and adapt. So that way we can keep this mission moving and, to ensure as much mission success as possible.
Great. Here's a question in the chat from Chelsea from space.com. And I wonder, Dr. Chancellor, you might be able to answer this. Chelsea's wondering, she has a question about application, and she's curious to see how you foresee the data from this work informing existing human spaceflight programs like Artemis and upcoming anticipated crewed missions to the moon.
Sure. So, it's actual measurements of the radiation environment on the lunar surface, and we're in between this one and hopefully, and on the IM-2 mission, we'll have data sets from 2 different locations on the moon, which provides exact knowledge of what is expected, not only for humans. So, in most cases, you can't shield or attenuate the galactic cosmic ray environment enough to fully protect the crews or astronauts. So what you want to know is what is the intensity of the environment, so we know how long they can operate, or what is the requirements that need to be set in terms of countermeasures and mission length. And not only just the humans itself, but also, well, if the environment is this intense on the surface or not intense, what is the structure of the habitats that we need to build? How much shielding do we incorporate in order to try to minimize the impact to health on the astronauts in their habitats? But it also gives insight to the nature of the environment for hardware, because it is susceptible to single event upsets or degradation because of the radiation. So it's all good measured data that will be used for understanding and assessing this risk.
Are there any other questions from the reporters? If you'd like to, you can raise your hand or drop it into the chat. If there's any other questions at all, just let us know. I'm going to put a link to some box images that were in this presentation, including Kaylee's design, for anyone who wants to use them, and some of the illustrations that explain the device. And Dr. Chancellor, is there any last words that you'd like to share?
I mean, there's lots. I mean, there's so much going on here, but it's just really exciting. I think, a lot of people hesitate on having a student driven mission like this, but you can see why I felt confident in having the students participate in this and be the ones who drive it. Obviously, they're very excited about it. They're very competent. They have a lot of passion and grit, and that's typically what you need to succeed. So it's really cool to watch it come together. I know there's been some questions about the patches itself. So LSU is licensed it, and they're finding a local manufacturer to create shirts and stickers, posters, whatever, and have you. I think it's going to be sold on the campus, like in the LSU bookstore, but it's also incorporated with Lands End. So I think by the end of the day, I should have the link to their storefront, where if you want to, you can go and purchase like the shirts that Haley and Katie and Jacob wore in the original story, or something similar to what I'm wearing right here, and put it on whatever garment they have available for that typical image. And I should have it on our website, the group's website, hopefully by the end of the day.
Great. If there's no other questions or any other comments, last words, we will end this virtual press conference. So thank you everyone for attending. We really appreciate it. And feel free to reach out if you have any other questions. Great. Thanks. Good job.